So my name is Uli Pinster from the European Microsoft Innovation Center in Aachen, Germany. I have the pleasure to show you the results of a European collaborative project called VNOC, where the European Microsoft Innovation Center and Microsoft Research works together with 14 partners from 7 European countries on bringing cloud computing to the scientific community. The nice thing about cloud computing is that it gives you the computing power when you need it. So even relatively small organizations that could not afford its own data center can use cloud power resources whenever they need it. And you don't have to be a big player in order to work on your great ideas. That is the aim of the VNOC project, and VNOC is applying this to a number of different topics, for example, structural integrity of buildings or the impact of global warming on the biodiversity. And I'm showing you here an example where cloud computing helps to predict wildfire outbreaks in the south of Europe. We are looking at the Greek island Lesbos, and this small island has suffered from 50 wildfire outbreaks only in the last summer. And we see an example of burned area here on this map. So predicting wildfires is pretty complex, so you have to take into account, of course, weather forecast data, socioeconomic parameters, the vegetation, the topography of the island, and things like that. So it's a pretty computing-intensive task to compute the chance that a wildfire outbreak might happen. But once you can do that, you could pre-deploy firefighters at dangerous areas just to prevent that the actual outbreak happens. So we have applied all this into a Bing Maps and Silverlight based application, and all the computing is running in the background on Windows Azure. I can start a simulation, and what the program is now doing, again in the cloud, is computing 120 of these overlay images, 1 per hour for the next 5 days. So here you have a look what happens behind the scenes. So we are computing at the moment with 46 PC equivalents and computing these 120 images, and I can scale that up and down as I need it, or as the real customer would need it, like then the government officials in Greek or wherever. So going back to the map view, we have now this overlay where blue means relatively low chance of a wildfire outbreak, green is a medium level, and if it gets towards yellow or orange, then this is a high dangerous area. So if I run now the animation, we are cycling through the 120 images. You see some high dangerous areas here. Again, it's a very complex calculation that is happening here. And so the government officials can then pre-deploy firefighters as they see it needed. If I run it once more, have a look, you see nicely day and night rhythm, and you will also see a rain cloud coming from over the northern part of the island towards the end now. The algorithm itself comes from the University of the Aegean, so they are experts in wildfire prediction, and we applied that to a cloud-based application. So that gives this relatively small university the opportunity to have computing power at hand that typically only large universities would have. So they can explore their ideas and don't have to buy, operate, or maintain a large data center.